Immersive analytics is a young, quickly evolving research field that unites work in visualization, immersive technologies, and HCI. To help guide this new area, we present 17 key research challenges identified by a diverse group of international experts and based on a virtual workshop that we conducted at ACM CHI 2020.
In 2015, immersive analytics has been defined as to explore the applicability and development of emerging user interface technologies for creating more engaging and immersive experiences and seamless workflows for data analysis applications. Since then, the field has produced advances in a range of areas. For example, empirical studies investigate perception and interaction compared to more traditional displays. Interaction techniques are being investigated for tangible and haptic interfaces. Specific application areas are explored, many of which require visualizations to be situated within a real-world environment. Design and authoring tools now include tools for known programmers, and new commercial platforms bring immersive analytics to end users.
As CHI 2020 couldn't happen face-to-face, we decided to go ahead with a virtual workshop. We had 28 participants from the HCI and visualization communities. We met 4 times on Zoom over the course of 2 weeks and across 4 different time zones. After a series of inspiring lightning talks and asynchronous group work sessions, we split into work groups, and we have identified 4 topics and 17 challenges. The 4 topics were spatially situated data visualization, interacting with immersive analytics systems, collaborative analytics, and user scenarios and evaluation.
The first group of challenges relates to spatially situating data visualizations in our real-world surroundings. These include finding ways to accurately link existing data sources with relevant spatial locations and making use of semantic knowledge extracted from the environment. While there's a growing body of evidence that spatial interaction can improve sense-making, more work is needed to understand the benefits of spatially coupling data encodings with their physical reference. There's also a need to better understand the cognitive processes of analytics using augmented reality for data analysis tasks. And finally, the requirements of immersive applications for detailed user tracking and physiological data raises a number of ethical concerns that must be addressed.
Interacting with immersive analytics system is uniquely challenging in part because of the combination of novel multimodal input and output technologies. Consequently, the challenges are how can designers better map interaction modalities to the most appropriate human settings, such as proprioception? How to enable multisensory output, such as vibrations, as feedback for input? How to support the multiple kinds of transitions, for instance, from using desktops where users have expertise to immersive analytics environments, which may be novel and unfamiliar. And finally, how to support complex analysis tasks using rich multimodal combinations.
While the possibility to facilitate collaboration is one of the key benefits of immersive technology, there are still challenges to solve in order to design efficient systems. Such system would of course need to support different forms of collaboration, from close to loose, from formal presentation to informal discussion. They should also support as much as possible face-to-face communication cues like facial expressions and hand gestures, but also one that go beyond what we can do in face-to-face, like changing our own size or use laser pointers instead of fingers. Such collaboration could be done from a wide range of immersive devices like AR/VR headset or displays or devices that have not been invented yet. It is then necessary to explore how we can translate communication cues done on one device for any other one, but also to explore how we can integrate this new device in current collaborative work practice and how we can assess them.
One theme that emerged in our workshops was on suitable scenarios for immersive analytics and developing methodologies for evaluating them. We defined 3 grand challenges as illustrated in the figure to the right. In defining application scenarios for immersive analytics, we addressed the challenge of identifying why certain scenarios lend themselves to immersive analytics while others may not. The challenge understanding users and contexts for evaluation of immersive analytics addresses questions surrounding who the end users of immersive analytics systems are and where they perform their work. Finally, we considered instrumental to establish an evaluation framework for immersive analytics for defining what attributes we need to consider when evaluating system performance and how these can be measured.
We hope these challenges will inspire the growing immersive analytics community, encouraging new discussions and motivating researchers who are new to the field. Immersive analytics offers tremendous potential to extend and enhance our experiences with data, and addressing these grand challenges will enable us to realize new opportunities in this innovative interdisciplinary domain.